Hi everyone, I'm Bhavana. Thanks for joining me for the session. Today I'm going to talk about how to accelerate your career via experimentation. Think of the session as a field guide. We'll hit experiment design patterns that work in the wild, the platform pieces that make experimentation fast and trustworthy, and the career moves that turn your work into impact. My goal is that you leave with a playbook you can start using this week. Before we jump into the session, let me take a minute and talk about myself and why this topic matters to me. I've spent over a decade helping teams design and scale experimentation, using data to build products and solve business problems, not just report on them. My core craft is experimentation and causal inference, choosing right design for the constraint, measuring impact credibly, and translating results into decisions. On system side, I design and operationalize experimentation platforms so the tests are reproducible, observable, and cheap to run. And strategically, I'm obsessed with connecting insights to outcomes, turning analysis into decisions leaders can trust, and building a culture where data informed is default. That combination, methodology, platform, and business impact, is what I'll share with you today. Let's quickly look at the agenda for today. We'll start with why A/B testing matters for your career, where experiments create value, and how to choose the right experiment design. And we'll dive into some basic statistical concepts and understand some of the techniques that you can use to speed up your experimentation, and then pivot to talking about how can you build experimentation portfolio, what are some of the tips for interview success strategies, and we will end this with an action plan. Now, let's start the session by talking about why expertise in the experimentation matters now. This is a high demand skill. It's highly sought after. It's a combination of data science, experiment design, and business strategy in a measurable way. Companies across all the industries are desperately seeking for professionals who can design, implement, and interpret experiments that drive real business outcomes. And additionally, with advancements in the large language models, LLMs are being used in every part of the life. It becomes crucial to validate the results through experimentation. Experimentation helps evaluate prompts, effectiveness, measure change in the response quality, detect biases, understand the overall model behavior at scale. Professionals who have this are indispensable. And the value of understanding core principles of A/B testing benefits everyone, not just data analysts. Engineers can build smarter experiment ready systems. Product managers can make evidence based features and roadmap decisions. It also has strategic impact through cross functional collaboration. Experimentation bridges data engineering, decision design, and product teams, helping you communicate insights effectively and influencing decision making across the organization. This skill makes you indispensable as the translator between technical complexity and the business value. Now, let's see where the experiment creates value. The answer is every department in the modern organization can leverage experimentation to make data driven decisions. You can see some of the examples here on the slide. These are only a few examples, but the key here is understanding which experiment approach work best for each use case and business context. And now, how do we choose the right experiment design? Let's look at what all experiment designs are available right now. The first one is A/B testing, which is a classic. This compares variance simultaneously, great for feature releases and UI changes. And the multivariate and factorial is used to test multiple elements and learn interaction effects. Holdout studies are used to measure long-term and network effects that accrue over weeks, months, and sometimes a year. Business constraints should pick the design, not the other way around. When the traffic patterns and the platform complicate things, switch designs. Switchback experiments are used to rotate by the time so that the same unit cycles through both the variants, ideal for marketplaces and two-sided platforms. Geo experiments randomize by the region. When user level randomizations risk spillovers, useful for location based features and marketing. If true randomization is not possible, use credible alternatives such as difference in difference, interrupted time series, synthetic controls. Difference in difference compares before and after changes in the treated group against a similar control group that didn't get the change. Interrupted time series looks at the structural brake right when the intervention happened. If the level or the slope jumps at that point and nowhere else, that's a signal. Synthetic control. When you change something in one big unit, say state or city, build a weighted virtual control from the other units that didn't change. So the pre-trend matches yours. Expert judgment matters. Choose designs based on constraint, technical capability, and intervention's nature. Know when to deviate from the pure randomization. Okay, now let's jump and take a look at the statistical concepts. I want to take a different direction here. In talking about basic statistical concepts, there are a lot of excellent resources online that can teach you about what exactly this concept is. But today I want to spend some time talking about tying these concepts to the business and why it's important for business. How can you think in those lines? First, hypothesis testing. This drives clarity. Knowing how to form good hypothesis teaches structured thinking. It's not about is it better, but what outcomes and why. The mindset helps align experiments with business strategy and ensures tests has clear success criteria before the launch. Second one is the confidence and uncertainty. This builds trust. Communicating uncertainty transparently builds stakeholder confidence. Leaders don't expect perfection. They expect honest ranges and risk awareness. This skill separates strategic thinkers from report generators. Effect size and power. This helps you prioritize what matters. Understanding these concepts helps you focus on impactful changes, not statistically trivial ones. The multiple testing disciplines. Today we run hundreds and thousands of experiments every month. With number of experiments and variants we test, there comes a need to control the false positive rate. This protects business from false wins and bad rollouts. The last but not the least, the fifth one is sequential and Bayesian thinking. In today's world, we see a need for faster experimentation. To improve velocity of experimentation and get continuous learnings, we need modern techniques like SQL and Bayesian to support adaptive learning. Now that we have looked at sequential and Bayesian, which drives experimentation velocity, let's also look at other techniques. In traditional experiment setup, we have to wait for the larger samples. This delays experiment time, insight, and thereby product development. If you look at sample size formula here, the sample size is directly proportional to the variance. Thereby, if you reduce the variance by half, you will reduce the sample size by half. By implementing variance reduction techniques, you can achieve statistical significance faster with fewer users. This translates to quicker decision making, accelerated product iteration, and more experiments run overall, driving rapid innovation and growth. Now that we have looked at the concept of the variance reduction, let's look at some variance reduction techniques. So the first one, which is regression adjustment with pre-period covariates. This is an umbrella for Cupid, ANCOVA, pre-post. We pick one or two strong pre-treatment predictors, adjust the outcome. This will help lower the variance. We will look at Cupid in detail in the next slide. Now let's go to the second one, which is balanced assignment at launch. This is blocking or stratification while you're randomizing. So treatment and control start equal on the stuff that matters. The third one is metric engineering. Noise in numerators and denominators and heavy tails blow up variance. Instead of aggregating per user or aggregated per user or cluster level, Vinserize extreme outliers and log transform the right skewed metrics. Cluster aware estimations. For geos or switchback tests, analyze cluster, block level, or use cluster robust standard errors. Exposure and eligibility hygiene. Count only truly eligible and actually exposed users. Freezing events definitions prior to the experiment. These are some few variance reduction techniques. Now let's look at Cupid in detail. Cupid is one of the vastly used variance reduction techniques. In Cupid, we reduce the variance by using the pre-experiment data that can help explain variance post-experiment. Let's look at an example. Say we want to run a test to see if people run slower with weights attached to them. The experiment mile time is a metric we get when we run the experiment, and a corresponding row will tell you if the weights were added. By looking at the data on the right, you can already see that the experiment mile time is influenced by how fast the runners already were, which is a baseline mile time. In this case, we can leverage the average baseline mile time to help explain the difference in the variance and use the change column, which is a difference between the baseline mile time and experiment mile time, to understand the impact of adding weights. What we are doing here is using pre-experiment data to reduce the variance that was explainable. Some of the best practices are using the variable that has high correlation to the variable of interest. When we are applying Cupid, there is no need to stick with just one variable from the pre-experiment period. We can use multiple variables if we believe that could reduce the variance effectively. Use baselines that reflect the normal behavior. Make sure the data only is from the prior to the experiment period, not from the period where the experiment is running. You can handle missing data by imputing the values. A call out for people who are interested. There are some advancements to Cupid methodology called QPAC, where in place of using regression model and single or multiple covariates from the pre-experiment period, QPAC uses machine learning models to predict the baseline metrics by leveraging multiple variables from the pre-experiment period. For those interested, I have attached a link to this at the end of the presentation. Please feel free to take a look. Now, in this new era, it's also essential to master the experimentation on LLMs and prompt engineering. So let's take a look at a couple of use cases where we can leverage experimentation to optimize large language models and optimize the prompts that we are giving the large language models. So the first one is prompt optimization, systematically comparing templates, few short examples, and system instructions to achieve superior outcome, quality, and relevance. The second use case for experimentation is model benchmarking, evaluating performance across different LLM architectures or fine-tuned versions of some effective models. The third one is RAG pipeline enhancements, optimizing RAG by testing retrieval strategies, chunking methods, and ranking algorithms. Fourth one is personalization and contextualization, assessing how dynamic content windows and user-specific data define models and boost user engagement. The last one is proactively identifying and mitigating harmful outputs, biases, and hallucinations through comprehensive and systematic testing. So there are a lot of use cases even within large language models and prompt optimization. And thinking about which kind of experimentation methodologies can you apply. You can leverage normal A/B testing, multivariate testing, or contextual bandwidths depending upon the requirement and the evaluation that you want to perform. For offline evaluation, you can use automated frameworks. Synthetic data can be leveraged, and we can use the LLM as a judge method for the faster iterations. Now that we have an idea of what experimentation is, basics of the experimentation, and how to improve the speed of the experimentation, let's look at some of the common pitfalls. If it seems too good to be true, it probably is. Whenever you find results that are extreme, it's always good to check against common pitfalls. Now, we can think of common pitfalls in 4 broad categories. The first one is technical implementation issues. That is sample ratio mismatch, logging gaps. When a unit of randomization is different from the unit of analysis, it inflates variance. The second one is experiment design flaws, interference and contamination because the units in the control and treatment have impact on one another. Statistical analysis errors. If you have a need to peak, adjust the false positive rate so that there is no room for p-hacking. Fourth one is contextual challenges and some additional challenges like metric drift, seasonality, etc. Now we have covered common pitfalls and A/B testing. Let's look at how to use this to accelerate your career. Understanding and practicing these concepts will enhance your analytical maturity. Shift your mindset from reactive to proactive experimentation strategy. This will also help you challenge opinions of leaders with evidence and guide strategic decisions. You will become a person bridging the gap between cross-functional teams, translating stats into business impact. All this will differentiate you in the market and make you invaluable. Now let's look at how to build the experimentation portfolio if you're just starting out. There are 3 key steps to building experimentation portfolio. Working and documenting realistic scenarios. Document the process showing problem identification, hypothesis development, experimental design choices, statistical methods with a clear business rationale. Start by contributing to open sources. Contribute to experimentation frameworks and statistical libraries like a stats model, PyMC, etc. Show business impact. Think about end-to-end demonstration. Develop a mindset to iterate on idea instead of one and done kind of experiments. I also want to share some success strategies for interviews. Interview success in the experimentation field requires not only technical expertise, but also mastery of concepts and being able to explain it in simple terms to stakeholders. Prepare specific examples where your experimentation work drove measurable business outcomes. End-to-end experimentation knowledge on how experimentation fits into the larger ecosystem and how to run experiments at scale. A combination of these three would help you be successful in interviews. For anybody who is starting out, you must be curious on how the trajectory of an IC looks in data science field, specializing in experimentation. So here is an outlook. This is a broad view of how the trajectory would look. An entry-level candidate would be expected to have rock-solid A/B testing fundamentals, clean hypothesis, reproducible analysis, and clear writing. When you think about the mid-level, it's the person in this role will be leading multiple experiments, mentoring analysts, diving into sequential and standardizing guardrails. A senior would set experimentation strategy, partner with engineering to drive the platform, experimentation platform, drive cross-function, cross-org decisions with quantified impact. Principal or staff would shape the system, develop roadmaps, contribute to open sources, conference talks, teach the organization on how to. So this is a general idea of how the trajectory would look. Now, to summarize everything that we have looked at till now, there are three key takeaways. The first one is develop deep technical expertise. The second one is pair it with strong business acumen. Last but not the least is master end-to-end experimentation ecosystem. Together, these three form foundation of successful career. I will end my talk with the action plan. I would highly encourage for the people exploring data science careers to specialize in experimentation to start today. Engage with community, share the learnings and learn from the community. Stay current with emerging trends in experimentation. The experimentation field evolves rapidly with new statistical methods. Staying current would differentiate you from others. And with that, I'll end the presentation. Thanks for being here. Thanks for taking time. Please reach out to me on LinkedIn if you have any questions or simply want to chat about experimentation or career, or if you want to talk about anything else, I'll be happy to connect. Thanks for the time. Thank you. Thanks, everyone.